can't have one force without the other. They act on different objects. Are the masses the same?
No.
No. Are the accelerations the same?
No.
No. Okay? But
So the smaller the smaller the small car, the less the force is exerted on it. Therefore,
Same
right?
Same force.
No.
No, but
The force is exact. I can't push on you any harder than you push on me.
that's why the smaller the small car, the smaller the force.
Okay, push. You're going to do this.
Because the
Bend
small
your
car
elbow.
can't push hard
Okay.
against the other bigger
Okay,
car.
so lean forward. Okay. Now, don't grab it. Okay. Now push on me. Oh, that sucked. Okay. All right, push on me harder. Push hard.
Oh, I get the trick.
Okay,
Yeah,
got
yeah,
it?
yeah.
So you can only
Yeah.
push on me if I push back on you.
Right.
So then you can push harder and harder and harder and harder. But
Right.
is there a maximum force that SUV can push? Yeah. Right? Because there's some kind of give somewhere. It's not an infinite force that SUV can put on the Mini Cooper. Okay? But whatever force it does put on it, the Mini Cooper puts back
I'm
on.
considering the Mini Cooper's force on the
It's the
on the
same.
SUV.
It's the same.
And the smaller the Mini Cooper is, the less force it can exert on the
But
SUV.
I'm smaller than you. Here we go. Okay, push, push. Okay,
Right.
now stand up. Okay, so push.
Go get the scale.
Okay, so
Right.
now
They're equal.
there's going to be a maximum force you can put on me because
Right.
I'm going to start to slide backwards,
Right.
right? But whatever that maximum force is, that's exactly the amount I'm putting on you. So why the heck? Here's a weird question. If I push on him and he pushes on me, why don't they cancel each other out? Why do I end up sliding backwards? Like if I was on the cart and you pushed on me, we'd both go this way. Why don't they cancel each other out?
Forces come in pairs.
Because they're on different objects.
Yes.
The other part of the third law is they will be equal, they will be opposite, and they will be on completely different objects. For example, can I lift myself up into the air?
No.
I can't, right? I have to have an outside force to move me. I cannot put a force on myself, but I can put a force on a different object, and that different object can put a force back on me. So, if David pushes on me, here's me on the cart, okay? And David pushes on me, and here's David, and he's right here, and I am putting a force back on him. And these two are equal and opposite, here and here. They are third law pairs. But I end up accelerating this way. How come? Look at just me. There's maybe a little friction here, but is there a net force to the right? Right? This is big, this is little, this is 10 newtons, this is 1 newton. I have F net equal to 9 newtons. I'm going to accelerate to the right. Now I look at David. What else? Do you see the angle of his leg? Nobody walks like this. We don't. We have to bend our leg and push. And when I bend my leg and push, do you see an X component? Like here it is a diagonal. There's some of me is pushing back and some of me is pushing up. Okay? So I push against the ground and the ground pushes against me. So if I draw this on David, then he's got this. Right? So if we just look at David, the reason he can go forward is because he's got a much bigger force to the right than to the left, so he can come. So the trick is they are equal, they are opposite, and they are on different objects. And if that's confusing to you, it is confusing, and I wouldn't really worry about it too much. Okay? But that's the kicker on a lot of those conceptual tests. If the cart pulls as hard, if the horse pulls as hard on the cart as the cart pulls back, how does anybody ever get anywhere? Right? Because there's an outside force. Okay?